Okay, this is day 6. You have packet page 48 for homework. We're going to be on Monday on the back side of our warm-up sheet. And we want to evaluate this series. So even if it didn't say series, we would know it's a series because the plus signs in between the terms, as opposed to a sequence, which would have commas. Our first question should always be arithmetic or geometric. Well, sometimes it's helpful to look down a little bit. -4 to -14, that's going -10. Well, this is also -10, so we're adding a -10 each time, which tells us arithmetic. So we would use our formula that we have to memorize, our arithmetic series formula that we worked with yesterday. So we're doing the first 18 terms. So we've got 18 over 2. Our first term is 6, plus we need to figure out what our 18th term is. Remember, in this formula, if you don't know something, it means you probably got to go to the arithmetic sequence formula from the reference sheet. We're going to find the 18th term. So 6 plus 18 minus 1 times our d value of -10. If we punch that in, that's going to give us -164. So kind of like we saw with the other negatives, you can do plus a -164, or plus a minus is just a minus. So you can put the -164 in there if you want to. And when we punch that on the calculator, we get -1,422. So those were arithmetic series yesterday. Today's topic is geometric series. Again, where the individual terms get added up, but the pattern from one term to the next is multiplication. Before we get to that, we'll just freeze on each homework question for a second. Remember, you can pause it, check your answers. Ones that you have questions on of where things came from, just post that to the content on the discussion board, and I will respond to those there. All right, so we're going to start on packet page 26 today. And we've got here sequence versus series. So a sequence, again, is a list of numbers on the left there. On the right, we have a series because the individual terms are added together. Now, these are both showing geometric because from one term to the next, there is a multiplication pattern of ×3 in this case. So you could add them all up individually, that's the long way, or there is a formula. And this is on your reference sheet. You do not have to have it memorized. So we're finding 1, 2, 3, 4, 5, 6 terms. So we would be doing S6. Our A1 is 3 plus 3. Just like in our geometric sequence formula, get in the habit of putting R in parentheses. If you don't know what R is, remember you can just do the second divided by the first, which in this case would be 9 divided by 3, which is 3. Then we're raised to the n, which was 6 terms, over 1 minus our r. So that 3 on the bottom is the same as the 3 in the parentheses. Now, when you go to put this in your calculator, let's take a look at that, because lots of people make mistakes putting this in the calculator. Start out, do control division to get your fraction button first. And now just put the things in the numerator and denominator as they go. Okay, don't try and type in the numerator and then hit the divide button because it's not going to go in correctly. And when we do that, we get 1,092. All right, so we're going to skip the top of page 27 and let's go down to the bottom. They're telling us we want to find a sum, so that means we know we're doing a series. But the question we should always ask is arithmetic or geometric to start out. So 4 to 6, you're adding 2. 6 plus 2 is not 9, so that means we must be doing geometric here. So we're going to do, from our reference sheet, and I was kind of showing you here, but it's like the 4th or 5th one down on the reference sheet. It says geometric series there. So we have Sn is equal to A1 minus A1. Get in the habit of putting that R in parentheses to the n over 1 minus R. So we're going to have S8. 4 is our A1. Now our R. Remember R, if you're not certain, we wrote this on the front of our packets. It's one that you have to memorize, is A2 divided by A1. So we'll do 6 divided by 4, which gives us either 3/2 or 1.5. We're raised to the n, which was 8. And then we have 1 minus 3/2 in the denominator. Now when we put this in, if you chose to keep it as 3/2, it will give you a fraction back in the calculator. Or if you chose to put it in as 1.5, you would get 197.03125. This is okay, the decimal's terminating. If a decimal does not terminate, you've got to go to Menu, Number, Approximate to Fraction, and that'll switch your decimal back to a fraction. But if it's terminating, that's okay. Usually the calculator keeps it out to like 8, 9, 10 places, something like that. But if it's clearly ending fewer decimal places than that, then it's okay to leave it as a decimal. So here's just another way a geometric series could be given. We know the summation symbol from the other day means you're adding. And then we know it's geometric because it's in that exponential form, a times b to the x, or a times b to the n. So we could take our formula from our reference sheet, and then we would have to figure out what each of the spots is. Well, if you sub in 0, 3 times 2 to the 0, that gives you 3 times 1, which is 3. So our A1s are just 3. The R is what you're multiplying by over and over again, and that's just what the B value is, so 2. Now our N, if we start at 0, 0, 1, 2, 3, 4, 5, 6. So that's 1, 2, 3, 4, 5, 6, 7 things. So N is 7, and we'll have 1 minus our R on the bottom. And this is S7 that we would be finding. Now, you could just put that summation in the calculator as it is, but we're trying to practice today using the geometric series formula that's on your reference sheet. So that's why I'm having you put it in this way. And if we put it in the calculator, we would get 381. So we are going to go to the top of page 29. And we're going to look at 27 Part A. So Deshaun is in his 5th year of employment as a patrol officer for the Metro Police. His salary for the first year of employment was $47,000. Each year after the first, his salary increased by 4% of his salary the previous year. What is the sum of Deshaun's salaries for his first 5 years of service? So the first question we always want to ask in this unit is arithmetic or geometric? Whenever you're changing by a percent, that's automatically geometric. Because we want to find the sum of the first 5 years, that means we're going to do the geometric series formula. So we're going to have Sn equals A1 minus A1 times R to the n over 1 minus R. And again, that's right off your reference sheet. You can be having that out as we're doing these. We want to find the first 5 years, so we're doing S5. The first year was 47,000. Now the R. Whenever you have a percent, You always start with 100%. If you're increasing, you'll add to that. If you're decreasing, you'll subtract from that. So we are increasing. So 100% plus 4% would give us 104%. And then if we move it over twice, we get 1.04. If you put just 0.04 in, that would show actually a 96% decrease, because that's 96% drop from 1 or from 100%. Our n we said was 5, and then we have over 1 minus 1.04. Now, these questions are one of the most popular ones on the Regents exam from this unit. This type of question, and then the recursive formulas that we did like on the first day, those are the two most popular questions from this unit on the Regents exam. So if we sub this in the calculator, we end up getting 254,567.16. So that would give us choice D. We're going to skip part B, and we're going to do part B down on the bottom for Maria. Maria earns $50,000 a year at her job, and she has promised a 5% raise each year. What will be her cumulative earnings if she stays at the employer for the first 10 years? So first off, what's meant by cumulative? Cumulative means you're adding them up along the way as you go. So cumulative earnings for the first 10 years means we want to add up all of her earnings in the first 10 years to find some total amount that she made in those 10 years. So because we have a percent, that tells us geometric. Because it's cumulative and we're adding them up, that's what tells us series as opposed to sequence. So we should go to our reference sheet, write down our geometric series. We're doing the first 10 years. She started out with 50,000, that's our A1. Our R, well, we start with 100%. She's getting a raise of 5%, so that's a plus. So that's 105%, or in other words, 1.05. Then we are raised to the n, which was 10, and then 1 minus our r of 1.05. Now, because we're dealing with money, and this doesn't tell us where to round to, we should round to the nearest cent, because that's where money gets cut off. When we put this in the calculator, we end up getting $628,894.63. So we're going to skip ahead to page 31, to that slide there. So this is the fourth formula that you have to memorize. It is our infinite geometric series. An infinite geometric series, if you are adding something smaller and smaller each time, so it's getting closer to 0, then your sum should approach some value as it goes to infinity, because eventually the values you're adding on are so super tiny. So just to wrap your head around that, imagine you had a pizza, and on the first day you ate half the pizza. Then on the second day you eat half of what's left. So in other words, a quarter of a pizza. Then the next day you eat half of what's left. So there would be an eighth of a pizza. And the next day you eat half of what's left. So that'd be a 16th of a pizza. And each day you just always ate half of what's left. Well, you're never going to eat all of it if you're always just eating half of what's left. But eventually, the amount of pizza you've eaten altogether will approach one whole pizza. So that's the idea we're working with here. And this is just multiplying by a half each time, so that is a geometric series. So I'd like everyone to go to the front of their packet. And I'd like you to write infinite geometric series. Okay, right underneath the other four, we have the D, we have the R, and we have the arithmetic series, right? The infinite geometric series. Now, what this part is just saying is R has to be less than 1. Because say if you were multiplying by 2 or 3, then your values would get larger. If you're less than 1 and multiplying it over and over, they'll get smaller. Because this only works if the values are getting smaller. So, let's practice one. We want to do S infinity. Our A1 is just 54. Remember R, if you're unsure, you do the second divided by the first. So we're going to do 18 divided by 54, which gives us 1/3. So we'll have 1 minus 1/3. And if we put that in the calculator, we'll get 81. So if we added these terms on forever, it's going to approach the value of 81. So an infinite sum is telling you what you're approaching, it never actually technically reaches there, but it's telling us what it's approaching. And we're going to do one more problem. We're going to do the one on the bottom of page 31. The value of an infinite geometric series S infinity is 12. Okay, so when we see that, we want to hopefully have this formula memorized. S infinity, we know is A1 over 1 minus R. Well, they told us that S infinity is 12, so the left side is 12. We want to find the common ratio, so we don't know R, and the first term is 6, so that's A1. Well, what we can do is we can just cross multiply. We'll get 6 equals 12 minus 12R. We can subtract the 12 over. That'll give us negative 6 equals negative 12R. We can divide by negative 12. And that'll be a half equals R. And that's our common ratio. That's what we were looking for here. And that makes sense in an infinite series. It should be something that is smaller than 1. So that looks like it can work out. And that's it for today's video.